Today and welcome. So picking up from what we talked last time, what we talked on our instantiating. So basically, we are trying to create enemies around our player. So we're creating enemies around our players, and then moving the players to collide because then the player is the cube, that the enemy has the stem. So once the player collides, then once the player touches this game object, we get destroyed. So the technique we'll be using is we'll be instantiating the enemy prefabs, the enemy object, the enemy game object around the player on the platform, and then once the player collides, then they get destroyed. So we'll be moving on to the scripting now. So we created a script called Instantiate Manager. So let me just right click on the hierarchy folder. So remember what hierarchy was changed on the scene. I named this scene as an scene. So create an entity or name this in spawn manager. Just spawn as in creating. So the name is spawn manager. So this spawn manager will be given it this script. So I will be attaching the script to spawn manager. So I just enter the script and you're going to click on the script to open it in your IDE. So now, so basically header is just shows up in our unit. So this kind of makes it that the right or something. You really don't need this one extra. But I love having the reference. So I need the reference to the public means we want to be shown in the editor, and then it can also be used from other scripts. So I doubt if you're using it from other scripts. So if I use private gameObjects, the gameObjects is what depending on the prefab we're trying to instantiate. So basically, private means it will show in the editor, and we will have to attach let me just use public to change the example later. So the means I'll be using public is this particular let me just say something. So probably we will definitely prefab. And remember we will attach this instantiate manager to the spawn manager gameObject. So if I come back to anything here, let the script load. You can see we have this little space where we can attach a game object. So you can drag and drop any game object. So that's why I use the word public, so that we have it shown in the editor, and from the editor I can just attach any game object that I want to remove on, that I want to instantiate, that I want to clone. So let me go back to my script. Then I have a function. Let me create a simple method. Let's say called create enemies clone. Create enemies clone. So basically, I want them to create in the scene now. Okay, so let's have we have integer number of enemies. So this way the number of enemies is create. So now basically I'll be so now I can do this. Okay, let me just do this first. So instantiate. What am I trying to instantiate? If you need to see this, it means what? It needs the object original, the prefab. So that would be enemy prefab. So that would be enemy prefab. So basically, if I run this script, it will create this enemy prefab this in the same position as its parent. But I don't want that. I want to be able to supply the position. So if you watch my 3D intro to 3D, I told you the position in Unity is in three dimensions. You have what? You have the x axis, the y, and the Z. So I don't know how you actually want to visualize this. Let me just go through it. So basically we have your X, you have your Y, and then you have your Z. So that's actually how the total dimension works. So for example now, if we have a string, let me just, so now if I want to create my, record that the position where this enemy one is sitting, let me mention that. The position where this enemy one is sitting, you have it on the X, you have it on the Y, you have it on the Z. Which means if I want to create another enemy here, right on this position, I have to get the X axis, the Y axis, and the Z axis. And the Z. So that will create another enemy right here. Then if I want to create another enemy, let's say here, I will have to supply with the X, the Y, and the Z. And you can't actually start doing that now and then. So the best way to do this is you can supply a value to a random variable. So the random variable, this actually just makes it randomized. So the random variable would generate three numbers for us on the X, on the Y, and on the Z. But since the Y represents the height, so we can just make that one fixed. So we can have it at, let's see, we can have the Y at, notice this Y function, we can have it as 0.57. I think that makes it fit on the platform. But from here to here is this. From here to here is what? The X. So let me look at it. Since we did in the forward. So I can just generate it at any random position from the start of this platform. So from the start, so I can generate it in any position from to here. So which means if I want to get this particular position lies, so what this is this right, this is this, and this is the X. Yeah, this is here. So this is minus X, and this is minus X. So if I want to get a value right here, it would be not actually on the minus X value. I shouldn't actually have done this. So it would be here. So that's actually neglecting the height. If I'm neglecting the Y factor. So if I want to instantiate this here, I have to get the width here, the X, and then the Y. But if I should alter the Y, I actually have to create a clone somewhere up. So if I want to instantiate it here, which means I would have to get this and this. So naturally, I can just, instead of that, I can just supply the maximum Z value. So this is the maximum Z value, and this is the minimum Z value. This is I don't know, this should be the maximum X value, and this should be the minimum X value. So that's just simply like saying the size of this platform. So I can now ask a particular function called random.range to supply me any value. So it will just randomize. It will supply it here. So if you just see it in action, let me just actually show you that. Let me show you. So now it needs a position, right? So now what I can do is I can just create a variable that stored in vector3 format. So vector3 format, enemy clone position. So now new vector3. So naturally I would have to supply probably 0.6. So it would create, now I cannot supply this particular value here. So which means I'm telling you to create this prefab at this position. So sorry, it's not a transform. So but let me just continue with it. If you actually create it at this particular position, but instead of doing that, now if you have create, let's say 5 more enemies, then we'll do it now. Change this value every time. Instead of doing that, I could just create a float x position. What I'm saying is to use, it should give me a value between the minimum x value. I will actually be creating this variable later, the minimum x and the maximum x. So the same thing applies for y also. I mean, for z. Remember, we're not setting the y position since y indicates the height. So I want everything at the same height. So minimum z and then the maximum z. So we haven't created these values. So let me just come in. So since we are going to set that in the close, we're going to set that in our inspector. So and then the maximum. What I'm only wanting this one to be for you to create a random value for us between the minimum and then the maximum. Okay. So and then using the generated value as our position. So we have a random position to instantiate. So that will be good. I don't know why you can say something. So English should return a random value between this and this, save it here, this and this, save it here, and then we'll be using those random values here. So now this vector that is generated here will be saved here, and then will be that was what we'll be using for our position. Now after supplying the position, you also have to supply the rotation. So for determining the identity simply means at no rotation. So save the script onto S, I just file, and then I don't know. Save. So just this onto S. Now, because this function here, create an image here. So let's go through it again. It generates a random value between minimum x. So we'll have to set the minimum and maximum x and z value based on the height and then the width of our platform. So and then we are creating a vector 3 from this random generated x and this random generated z, but we are making this 0.6 since we don't have to set the height. Just make sure it's on the platform, and then we are creating the prefab. So let me see this script on the beam. Let it load. So once it loads, I will be deleting this too. Okay. Come to our form manager, make sure okay, I haven't actually attached this enemy prefab. So from the prefab folder, make sure you're dragging from the prefab folder, drag this enemy gameObjects and drag it here. So now the minimum x and my maximum x. If you would notice this platform, so these are zip. Remember this blue arrows are zip. So you would notice the player zip. I want to take the player zip. So the maximum is 5. Let's do 5, and then the minimum is what? -5. So the same thing applies for the x. So the maximum is what? -5. I mean the minimum is -5 and the maximum is what? 6. If I come to my farm manager, minimum for x I'll be doing x to -4, the maximum is 4, minimum is let's do 4 again, and let's do. So leave this number of enemy for now. So now once I run my script, Unity will generate a random number between x and z using their minimum and maximum value, and then create an enemy prefab. See that? and you see it's an enemy clone. This position, if I should run the same script again, it won't be instantiating at that same position. So that's the usefulness of that random dot range. So now, since we know that works, I'll be using a for each loop. So simply what for each will do is for each will take the number of enemy and then create a clone every time. So let me just do that here. Let me just do that here. I mean that's for a follow. So a follow, I'll just replace my follow integer equals to 0. So if it's less than the number of enemies, then increment the value of this. So what I'm saying is it should keep calling this function. It should call this create enemy clone function this number of times. So what this will simply do is this is how the script is going to run. So once it comes here, I is 0, it makes I 0. So it checks this is what we call this is the instantiation and this is condition. So it checks if I is still less than the number of enemies. If I is still less than, so let's assume we set a number of enemies 4. So I is still less than the number of enemies 4, then that's correct. It proceeds to this next one. It increments I, so it sets I, so I is now 1. So what would that do? We call this function. What does this function do? It creates an enemy at a random position. It comes here again. This loop will still keep running until this condition is what is false. So it comes here again. I is now what? I is 1. Remember I is 1. So is I still less than number of enemies? Is 1 less than 4? That's correct again. So it increments I. I is now 2. It comes to this body, this particular body, and then calls this function again. So it creates another enemy at a random position. It comes here again. I is still less than the number of enemies. So 2 is still less than 4. 2 is still less than 4. That's correct. It comes here. It increments the value of 2. So that makes it 3. It calls another. It creates another enemy. So it does that till I is no more less than the number of enemies. So that's what that does. So now hopefully if I come here, I'm going to make it just the biggest function. So now number of enemies, let's put that at 5. So now it's going to keep creating our enemy clone this number of times. That's what the for function is about. So and the reason why I'm putting it at start is so well, so just for that function at start. You at all it in update it, keep running that same function for what as each frame per second. So you see that. So the mainly only issue here we have 9 is actually created this one, but actually that's not a big factor for now. We can just use that for it. Although it doesn't collide now, we touch that in our lesson. So it works. If I set this to let's say 9, the number of enemies is 9, and I run it. So we do that. So a quick recap. What we are simply doing is we are getting a random position value by using a random reference. So it supplies us a random value from here, from here. I mean the platform. So it's giving us a random value from here. A random value from here to here. You know this is 5. If you check the platform, so this is 5 units and then this is also 5. No, is that fine? No, that should be correct. Basically, that's okay. What I'm trying to say is it's giving us a random value from here to here and then from here to here. So let's assume it chooses here and here. So it will instantiate the object right here. If it chooses here and here, it will instantiate the object right here. You get the logic, so that's basically how it works. So now next video we'll be talking about destroying and also hopefully about object pulling. See you in the next one.